and last week we worked on the project schedule, and we have left to do, according to our project schedule, the financial analysis, the safety, the video update 4, the financial report, the poster presentation, the peer evaluation 3, and the course evaluation. Well, this week we worked on the design concept. Basically, the design that we have chosen is the pitching machine design. In this design, the ping pong balls are fed into the launcher one by one, and this design uses 2 motors to spin the ball to achieve the desired trajectory. The balls fed into the launcher can be shot to follow the desired path by controlling the speed of the motors. This project involves 9 cups on the board, so by using this design, the trajectory for each of the cups can be set. Or in other words, the ball can be spun in 9 different directions to be dropped in the corresponding cup. Now, to control the ball's trajectory, as I just stated, there are a total of 9 bends that the device can aim for. So the device will have a total of 9 preset directions that will aim for each individual bend. In order to do this, the speed of each motor will be adjusted to get the appropriate speed and angle. And this is the diagram for the proposed concept. Now, in order to obtain the desired direction, each motor must have a separate direction. The simplest angles would be bend 2, 5, and 8. Here's an example. So if we let S equal the speed of L, and then we let S naught equal negative S, which is equal to the speed of R, then to obtain an angle of 0 degrees with the ball's launching point being the reference, S equals S naught. So if S represents the positive velocity, S naught equal negative S, then to shoot the ball at an angle greater than 0, which would be in the right direction, we would use the equation S is less than S naught. And to shoot the ball at an angle less than 0, which is in the left direction, we would use the equation S is greater than S naught. Now, to negate the acceleration constant of gravity on the ball, each launch setting will have to be enough speed for the ball to reach a bend without hitting the front of the bend. This can be further calculated, but may pose a more complex equation for calculations. So this will be done with trial and error, meaning different voltages will be sent to the motors to obtain the desired speed and direction. This can be done because for each distance, the angle can be consistent as long as the speed of one motor has a constant multiple speed of the other. The direction of the ball will not be a straight line due to the spin of the ping pong ball. The diagram only is concerned with the initial and final position. This constraint will not be a factor of the launch device because the input angle will only control the speed of the motors, which controls the direction. So for the control system, the algorithm used is a decision tree to implement a no-loss strategy. The first move of decision tree is that if a player moves first, then it moves in the top right corner. Else, if the player goes second, then it moves in the center. The decision tree is implemented after the first move and looks for the best opportunity to win by creating a tree of all the possible moves. The canceling algorithm is used for either blocking or overcoming a block. If an opponent blocks a win move, then we use canceling to cancel out the blocking move and win the game. If a loss is detected, then canceling is used to block the winning move. This is our feeding mechanism. So the balls will be held all the way up the rail. We will then use a servo motor that will release the ball at a correct time. Software will control the motor to release the next ball being shot. The servo motor will step just enough to let one ball release down the rail to the motors that will shoot the ball. The rest of the balls will be stopped until the next ball needs to be released. We will use the potentiometer as we did in Research Project 2 to find the correct position the motor needs to be in order to release the ball.